Hello, this is Mr. Stansbury. I'm going to take you through the notes on antidifferentiation and indefinite integrals. Okay, at the end of this, you should be able to say I can differentiate and find the antiderivative of a function. Okay, so antidifferentiation, a big word. It's the process of finding y from dy over dx or f of x from f prime of x. So it's the reverse process of differentiation. Okay, so with that, if you have a function and you differentiate it, you take the derivative, you end up with this, right? Dy over dx or f prime of x. And then if you have this and you want to go back to find the original function, that's called antidifferentiation, right? And get you back to this. And it's kind of this little loop for the most part. Okay, each function has one derivative, but each derivative can have infinite many antiderivatives functions. Let me show you what I mean by that. So let's say we have f of x equals x cubed. To take the derivative of that, remember we take the 3, move it out front, subtract 1 from that, so we get 3x squared, right? So then if we take our we've got our derivative function and we want to anti-differentiate that. We want to turn it back into the original function. Remember, we add 1 to the power, which is 3, and then we divide by that 3. Okay, so that x squared now turns into a cube, and there's a 3 out front, but now we're dividing by 3, so those 3's go away, and we're back to x cubed, which is what we started with. But here's the thing. If you have the original function of x cubed plus 2, you take the derivative of that. The x cubed, we know, turns into 3x squared, right? But this plus 2 gets lost, right? Because really that's plus 2x to the 0 power. 0 times 2 gives us 0, so that's really plus 0, which disappears, right? We don't write that. Same thing if we have x cubed minus 5. If we differentiate that, we end up with just 3x squared, and this minus 5 disappears. Okay, same thing with x cubed plus 3 fluffy unicorns. It's going to be just 3x squared. This constant out here gets lost when we differentiate, and then when we go back to anti-differentiation from our derivative, again, this constant will not reappear because it turned into 0 out here. Okay, so the derivative of a function of the form f of x equals x cubed plus c, where c is some arbitrary constant, will give f prime of x equals 3x squared. Okay, the indefinite integral of 3x squared with respect to x is x cubed plus c. We write this as 3x squared dx. Okay, so there's our derivative. Equals x cubed plus c, and this is called the constant of integration. Okay, we'll show you where that's going to come into play here in a little bit. But the important thing is that you realize that this constant out here, when you take the derivative of it, that constant gets lost. So then when you go back to anti-differentiate to come back to the original function here, that constant, it disappears. It gets lost. Okay? Okay. So example 5 here says differentiate x to the 4th and hence find the antiderivative of x cubed. So for that, we're going to differentiate first. So we've got x to the 4th. So remember, if we differentiate that, 4 comes out front, and then we subtract 1, right? So this ends up being 4x cubed, right? So d over dx of x to the 4th is 4x cubed. So this is saying that's the derivative of this. Okay. Now, what they're saying is use that information that we just came up with to figure out what the antiderivative of x cubed is going to be. Okay, so if we want to find the antiderivative of x cubed, we know that the derivative of x to the 4th is 4x cubed. So what we can do is we can use this information here to find the antiderivative of x cubed. So we can say d over dx, and what we want to have is, instead of the 4x cubed, is we want to have just plain old x cubed, right? So basically, we've got this extra 4 in here that we don't want, so we want to divide by that 4. So what we'd want to do is use this information here, x to the 4th over 4. That should end up equaling our x cubed, our derivative, right? So the derivative of this should be x cubed, right? So if you put the 4 out front, those 4's cancel out, subtract 1, and there's our x cubed. So basically what they're getting at, use the information that you got here to find the antiderivative of x cubed. We just ended up with a 4 that we didn't want, so we ended up just changing our function from x to the 4th. We'd want to have that as divided by 4. Okay? So antiderivative of x cubed is 1/4 x to the 4th. Okay, that's kind of what they're getting at. So for part B here, if you remember from our notes earlier, the indefinite integral of 3x squared with respect to x is x cubed plus c. We got to put that constant of integration in there. So for part B, our indefinite integral x cubed dx, what we want to do is we got to write that to make sure that we have that with the constant of integration. Okay, so we already found the antiderivative of x cubed is 1/4 x squared. So we write our integration, our indefinite integral of x cubed with respect to x is, our antiderivative, which we've already found, is 1/4 x to the 4th plus our c, which remember is the constant of integration. Okay, so that's all they're asking for on that one there. Okay, let's take a look at our last example here. Differentiate x to the 4th and hence find the antiderivative of x cubed, and then the indefinite integral x cubed with respect to x. Okay, so differentiate, if you remember, is just find the derivative. So we got x to the 4th. Remember, the 4 comes out front. Subtract 1 from the power, so we end up with 4x cubed. Okay, so there's our differentiation of x to the 4th. Now, the book likes you to have to use this to help you find the antiderivative of x cubed, but what might be more handy for you is just how can we find the antiderivative of something without any hints like this. So let's just find the antiderivative of x cubed, right? So we're going to basically do the opposite of what we just did for differentiating or finding the derivative of. So instead of subtracting 1, we're going to add 1, and then we're going to take that total and we're going to divide by that number. So 3 plus 1 is 4. So really we have x to the 4th over 4, and then a little bit nicer way to write that is 1/4 x to the 4th power. Okay, so there's our antiderivative of x cubed. Okay, so then with that, for part B, find the indefinite integral x cubed with respect to x is just going to be our antiderivative, 1/4 x to the 4th, right? And then we got to make sure we put on our c, right, which is our constant of integration, right? Because sometimes that c gets lost when we take our derivative, so we got to make sure we add that back on. All right? Okay, that's all we have for antidifferentiation and indefinite integrals. If you have any further questions, please feel free to ask. Thanks.